In this video we will look at straight lines, and before we get started we'll just look at how to do mathematics. So number and copy the examples and ask your teacher or tutor if there are any steps that you do not understand. Number your questions, and unless you have the ability to get fit while watching someone else run, you must do the questions on your own before watching the answers. Then mark your answers. If it is incorrect, write down the corrections and make sure you understand where you went wrong. This will enable you to do better the next time you attempt a similar sum. Now for an overview on what we will be doing in this video, we are first going to see how to determine the equation of a straight line, then we're going to use the equation, then we look at parallel lines, then collinear points, then perpendicular lines, then the equation of the median, and then finally the perpendicular bisector. So for the first example, determine the equation of a straight line. It says determine the equation of the straight line passing through the points 3, -1 and -2, -4. Now we know that the standard form of a straight line equation is y equals to mx plus c. So we have to find the gradient and we have to find the c-intercept, which is or the c value, which is your y-intercept. Now first thing, we know how to find the gradient because we know the gradient's formula is just the change of y over the change of x. So to do that, we just substitute in these values. So we have, let's just write this one underneath here to make it easier. So I'm going to have -1 minus -4 over 3 minus -2. And then I calculate that. So this is then, this minus becomes a plus, so -1 plus 4 gives me 3, and then these two negatives gives me a positive, so that becomes 5. Alright, so there's my gradient. Now I need to find the c-intercept. Now there's two ways of doing it. We can actually use this equation as y equals to mx plus c, or we can use the equation that says y minus y1 equals to the gradient times by x minus x1. Now this method in particular is actually much easier. With this one you just substitute in a point and the gradient and then solve for c. Whereas this one exactly the same, except the solving or putting it back into its standard form is just far more easy. So if I say y minus, and I can substitute in any of these 2 points, so let's substitute in the first one, minus -1 equals to, so the gradient we saw was 3 over 5, and then x minus x1, which is just 3. And then we just put it back into its standard form. So this becomes y plus 1 equals to 3 over 5x minus 9 over 5. And then we finally just want to isolate y. We have y equals to 3 over 5x minus 9 over 5 minus another 5 over 5. Or if I take my 1 over, it becomes, or let's just do that step anyway. So minus 9 over 5, and then taking the 1 to the other side, -1. So therefore, y equals to 3 over 5x, then minus 5 over 5. So this gives me -14 over 5. Alright, so there's my equation of my straight line in its standard form, where my gradient is 3 over 5 and my c value is -14 over 5. For question 5.1, we need to determine the equation of the straight line passing through the points 2, 1, and 6 and 5. Alright, so first thing, always just write down the equation of the straight line, because that just shows you what you need to get. If you don't know where to start, then if you wrote this down, you know, okay, I have to get the gradient and I have to get my c value. So getting the gradient, we just substitute it into the formula, change of y over change of x, right? And then we have my y value. So once again, I'm just going to write this underneath here and then say 1 minus 5. So 1 minus 5 over 2 minus 6. 2 minus 6. So this gives me negative negative 4 over negative 4, and that gives me just 1. So my gradient is 1. So now I'm going to use this formula, y minus y1 equals to gradient times x minus x1. Alright, and then we substitute in a point. So I'm just going to substitute in the 2 and the 1. So 1 for y, that's y minus 1 over there equals to the gradient, which is 1. So x minus 2, and then we just put it in its standard form. So y minus 1 equals to, if I multiply the 1 in, it's just x minus 2, and then y equals to x minus 2, bring the 1 over, it becomes plus 1, y equals to x minus 1. So my gradient is 1 and my c value is minus 1. Determine the equation of the straight line passing through the points minus 5, and 1 and minus 3. So y equals to mx plus c, that's my goal. First I'm going to find gradient. So gradient is the change of y over the change of x. So writing down 1 and negative 3 to make it easier for myself. Alright, and then we substitute it in. We have minus 5 minus negative 3, minus 5 minus negative 3 over minus 5 minus 1, minus 5 minus 1. Alright, now we have minus 5 plus 3 over minus 5 minus 1 is just negative 6. This then becomes minus 2 over minus 6. Now you can put everything here on a calculator, that's also okay, or you can just calculate it like this. So this is then just 1 over 3. Alright, so now we have the gradient. Let's just now substitute into the following formula. Y minus y1 equals to gradient times x minus x1. And then y minus, so my y1 value over here is minus 5 or negative 5 equals to gradient is 1 over 3, then the x minus negative 5 again. And then just to simplify all of this, we have y plus 5 and then equal to, so let's multiply the 1 over 3 in, so 1 over 3x, this becomes a plus, so then it is plus 5 over 3. And then just to simplify that further, or isolate y, we have 1 over 3x plus 5 over 3 minus 5. So let's see what that is equal to. So that's 5 over 3 minus 5 is equal to negative 10 over 3. So y is equal to 1 over 3x minus 10 over 3. Alright, so there's the equation of our straight line. Right, now determine the equation of the straight line passing through these points. Now we can go ahead and just use the, so we still need y equals to mx plus c, but if we look closely we see that both of these y values are equal. So what does that look like? That means that if I draw it on the Cartesian plane where we have minus 2, let's say minus 2 lies here and 3 lies somewhere over here, and this is where minus 1 is, right? So then your 1 point lies there and your other point would lie there, right? So that means the line that goes through these 2 points are exactly parallel to the x-axis. And whenever a line is parallel to the x-axis, the equation is very simple. You actually don't need to do any calculations to find it. You basically just see because the y value is constant, the y value, doesn't matter what point is on the line, the y value will always be equal to minus 1. So therefore, if the y value is constant, the equation of the straight line is simply going to be y equals to minus 1, and that's it. So wherever the line lies, let's look at another example. If a line lies up here, and this it cuts the y-axis at 5, then your equation for this straight line would just be y equals to 5. And for any value wherever it lies on the y-axis. Question 6.1, determine the equation of the straight line passing through the points 7, 3 and minus 4, 3. So now once again we notice that both these values are equal, the gradient values. Now if you do it the normal way, where you find the gradient using the change of y over change of x, your gradient is simply going to equal to 0. Now in this case, if I should quickly draw it, this is, let's say 3 lies over here, then the line would actually just look like this. So then, therefore, my equation is simply going to be y equals to 3, because y is constant at that point. Example 7, determine the equation of the straight line passing through the points 7, 4 and 7, minus 2. Now in this case, much like the previous example, except now both our x values are constant. So this line would then look like this. If my point of, let's say, 4 over here and minus 2 over here and 7 lies somewhere here, then my 1 point lies over there, my other point lies over here, and the straight line going through these 2 points are exactly parallel to the y-axis in this case. So that means that your x value is always constant. It's always on 7. No matter where the point on the line lies, its x value will always be 7. Now, in this case, you wouldn't actually be able to do it in the normal way where we find the gradient, because if you're going to calculate the gradient, then it would give you a undefined value on your calculator. So now you have to use the method where we simply say, okay, if x is always 7, then the equation of the straight line will simply be x equals to 7, because it's constant at x is always equal to 7. And that is the equation of this line. And once again, if you, for example, have another line over here, and let's say it's at negative 3, then your equation of that line would simply be x equals to negative 3. Determine the equation of the straight line passing through the points 8, 4 and 8, minus 1. So here we see both our x values are equal, and they're both equal to 8. Therefore, the line which goes through 8, maybe over here, that line is always, all the points are on 8, all the x values are 8, and therefore the equation of the line will simply be x equals to 8. So that was to determine the equation of a straight line. Now let's look at using the equation. Now, for example 8, the point 3y lies on the equation, or the point 3y lies on this equation. Determine the value of y. Now, whenever you have the equation, let's say if we just draw it, for example, it goes through like somewhere there, right? And you know the x value, so you know that the x value needs to be, let's say, over there. Then how do I find the y value? Using the equation. All I simply do is wherever I substitute the x value for any value on the line, if I substitute the x value in the equation, that would give me my corresponding y value. So all I'm going to do, where my equation is y equals to 2x minus 4, I'm going to take my given x value and put it into my equation. So y is equal to 2 times by 3 minus 4, which is then equal to 6 minus 4, and that gives me 2. So that means it actually lies somewhere over here where that point is 3 and 2. So therefore, y is equal to 2. Question 8.1. So this point lies on this equation. Determine the value of y. So all we're going to do is, we know what the x value is. which we will replace in the equation or substitute into the equation. So I have y equals to minus a half plus 7 of x plus 7. So in place of x, I'm going to put the value of x. So that's minus 2 plus 7. So multiplying this out, the minus and minus becomes a positive. 2 and 2 cancel, so this is 1 plus 7, and therefore it's equal to 8. So my y value is then equal to 8. Then for example 9, if we have the point x and 5 lies on this equation, determine the value of x. Now in this case, we need to find x and we are given y's value. So we are just going to take this 5 and substitute it into this equation where y is in place of y. So I have y equals to minus 3x minus 6. So I put in 5 instead of y, minus 3x minus 6. Now in this case, to find x, it's just one step harder because now we have to solve for x. Whereas if we substituted in x to find a y, we just substituted in the point and got our answer when we simplified. So to solve for x, I'm going to bring x over to this side and I'm going to take 5 to this side. This then becomes positive 3x, and this 5 becomes negative 5 minus 6. So 3x is negative 11. Divide both sides by 3. That gives us x is equal to minus 11 over 3. Right, 9.1. So the point x and minus 11 lies on the equation. Determine the value of x. So our equation is 2y equals to 7x plus 2. And my point x and minus 11. So what I'm going to do is just substitute in for y, the minus 11. So in place of y, I write minus 11 equal to 7x plus 2. And then I just solve for x. But first I'm just going to simplify this side. This is minus 22 equals to 7x plus 2. Right, and then I'm going to bring my terms that contain x to the left-hand side, my constants to the right-hand side. We have negative 7x equals to 22 plus 2. And then negative 7x is equal to 24. So x is then equal to negative 24 over 7. Okay, so that was using the equation, quite simple. And then we move on to parallel lines. Now, parallel lines are two lines that run straight or right next to each other. So they will go on for infinity and never touch each other. That's like thinking about a train, a railway of a train. They go parallel and they never touch each other. And parallel lines, we can identify parallel lines by their gradient. So their gradients, if this line has equation y equals to m1x plus c, and this one is y equals to m2x plus c, then their gradients will always be equal. And that makes sense because the gradient tells you how steep the slope is of a line. And obviously parallel lines have the same steepness or the same slope, so therefore their gradients are equal. Now let's look at how to use this. Determine the equation of the line parallel to this line and passing through the point. So now we need to find an equation, and remember, an equation of a straight line is y equals to mx plus c. So we need the gradient, but how are we going to find the gradient lies in this. The line is parallel to this line. And what do we know about parallel lines? We know that their gradients are equal. So this line's gradient will then be the same as this line that we want to calculate. So if I say 3y equals to 6x minus 9, I know my gradient for my standard form are the coefficient of x. But before we can actually take that, we first need to find, or we need to isolate y, because this equation is not in standard form. So to put this in standard form, I need to isolate y, get y on its own, and therefore I need to divide everything with 3. And in doing that, y is then equal to 2x minus 3. So now this line is in its standard form, whereas this is my gradient and this is my c value. And now because this line that I'm looking for is parallel to this line, I know, okay, my gradient will therefore be equal to 2. Now all I need to do is to use this point that it passes through to find my equation in its standard form, and we are going to use the equation y equals to, or y minus y1 equals to gradient times by x minus x1, the form as that, and then just substitute in our point and our gradient. So the point, the y value is 3, so y minus 3 equals to the gradient, which is 2 times by x minus 4. Right, now we have everything we basically need. We just need to put our equation in its standard form. So y minus 3 equals to multiply the 2 in, so 2x minus 8, and then isolate y, so 2x minus 8 plus 3. So y is equal to 2x minus 5. And there we have our equation that's parallel to this line and passing through the point M. Question 10.1, determine the equation of the line parallel to this line and passing through the point D. Right, so we know, what do we want? We want y equals to mx plus c, whereas we need to find gradient and we need to find c value. How do we find the gradient? We are given this piece of information. It's parallel to this line, which means that our gradients are equal. So let's take our line that they have given us and put it first to find the gradient, put it in standard form so that my y is isolated and my x is on this side. So first let's just take the x over, minus x plus 8, and then I need to isolate y, so divide everything with 2. So we get minus a half x plus 4. Alright, so there we go. That's our gradient. So therefore my gradient will be equal to minus a half. Okay, and then all I need to do is to substitute in this point into this equation, y minus y1 equals to gradient times x minus x1. So substituting that in, we have the y values is 4, so y minus 4 equals to my gradient, which is negative a half, and that is then x minus negative 2. And we have y minus 4 is equal to, so let's multiply in this and then also multiply these two together. We have minus a half x. This becomes a positive. So this is plus 2. If I multiply plus 2 with negative a half, it becomes negative 1. So you can check that on your calculator. And then we just need to take the 4 over to the other side. We have y equals to minus a half x minus 1 plus 4 when it comes over, and finally y equals to minus a half x plus 3. Alright, and then there we have it, our straight line in its standard form. So that was parallel lines. Now let's look at collinear points. Now collinear points are the following. If I have 3 points, for example A, B and C, that lie on a straight line, and I have another 3 points, also A, B, and C, but they do not lie on a straight line, then the 3 points that lie on a straight line are collinear, whereas the 3 points that do not are not collinear. So collinear points are basically points that all lie on the same straight line. And now, how do we know if 3 points are collinear? There's a simple test that we can do, and when 3 points are collinear, their gradients, the line AB, the gradient of the line AB should be equal to the gradient of the line BC, whereas in this case over here, this gradient of AB will not be equal to the gradient of BC. So let's look how we apply this practically. If I have example 11, determine whether the points P, R and Q are collinear. What I'm basically going to do is then just find, so we can actually first start by just drawing this. Let's say we have these 3 points, and we have P, R and Q. Then we have our coordinates, and if this gradient of this PR, so let's say the gradient of PR is then the change of y over the change of x. So that means change of y, or let's say yp minus yr over xp minus xr. So if I substitute in those values, where this is my x and my y for p, and same for r, then y for p minus 2 over minus 4 minus negative 1. So if we solve for this, simplify this gives us negative 4 over negative 3, which is then just equal to 4 over 3. Alright, now let's find the gradient of RQ. So the gradient of RQ is equal to my change of y of, let's say, q minus y of r over x of q minus x of r. Now let's do that substitution. Then y of q, which is 6, so 6 minus 2 over 2 minus negative 1. So 2 minus negative 1. Now to simplify this, we just have 6 minus 2, so that's 4 over 3. And now as you can see, this gradient of PR, which is 4 over 3, and gradient of RQ is 4 over 3. So therefore, the gradient of PR is equal to gradient of RQ, and therefore the lines or the points P, Q, PR and Q are collinear. So for question 11.1, determine whether the points B, D and M are collinear. So we can just draw a rough sketch just to get an idea. Here we have B, D and M. So therefore, if we want to find out if these 3 points are collinear, we need to calculate the gradient of BD, and we also need to calculate the gradient of DM. And then if these two gradients are equal, then we know that these 3 points are collinear. So let's start with the first gradient. We've got gradient of BD, and that is the change of y of B minus YD over XB minus XD. So let's just substitute that in. So YB, that's 1 minus 13 over change of x minus 6 minus 6, so minus 6 minus 6, and then simplify. We have negative 12 over negative 12, and that gives us 1. Alright, so now for the gradient of dm, we have change of y of d minus y of m over x of d minus x of m. So let's substitute in those values. So y of d, so that's 13 minus 7 over 6 minus 0, and this then is equal to 6 over 6, which is equal to 1. So therefore, my gradient of BD is equal to the gradient of DM, and therefore points BD and M, B, D and M are collinear. Question 11.2, determine whether the points A, B and C are collinear. So we have these 3 points where we have A, B and C. So gradient of AB we need to calculate, and we need to calculate the gradient of BC. So the gradient of AB is the change of y. We've got YA minus YB over XA minus XB. Let's do the substitution. So that is 1 minus negative 4, 1 minus negative 4 over 0 minus negative 2, 0 minus negative 2. And to simplify, that gives us 1 plus 4, which is 5, and 0 plus 2, which is 2. Then for the gradient of BC, we have change of y, yb minus yc over xb minus xc. To substitute in those values, we have minus 4 minus 8 over minus 4 minus 1, that's the y value, and then minus 2 minus 8, minus 2 minus 8, and then this gives us negative 5 over negative 10, which gives us a half. So therefore, my gradient of AB is not equal to my gradient of BC, and therefore points ABC, AB and C are not collinear. So those were collinear points. Now let's look at perpendicular lines. Now perpendicular lines are lines that cut each other at a 90-degree angle. And what is what we can know about the gradients of these two lines are this following formula. If this is line y equals to m1x plus c, and this line is y equals to m2x plus c, then these two gradients of these two lines, if I multiply the two gradients together, their answer will always be equal to minus 1. So that is actually a method that we can use to test whether two lines are perpendicular. We can find their gradients, and then we can multiply the gradients together, and if that equals to minus 1, then we can know that these two are perpendicular. Or if we're given the gradient of one line and we need to find the gradient of another line and they tell us that they are perpendicular, then it means we can use this formula to find the unknown gradient. So for example 12, calculate the gradient of the line perpendicular to the line 7y equals to 2x minus 7. Now before we can find the gradient of this line that's given, we first need to put it into its standard form. Now in order to do that, we know a line standard form is y equals to mx plus c, so we just need to isolate this y by dividing every term with 7. So I then have y equals to 2 over 7x minus 7 over 7, which becomes 1. Alright, so now that we have this line in its standard form, we know this is its gradient. So if that's the gradient of the line that's perpendicular to our line is 2 over 7, then I can use my formula. Whereas I'm just going to do it over here. So if I say my gradient, what I'm looking for, times by the perpendicular gradient is equal to minus 1, and my perpendicular gradient is 2 over 7, then if I solve for it, I get, well, if I solve for this m, I can just cross multiply. I have negative 7 over 2. Okay, so that's the gradient I'm looking for. Now this is one method by substituting in and solving, but another very easy way of finding this gradient is to just simply, if you want the perpendicular gradient, you just simply swap the numerator and the denominator around and you change the sign. So as you can see, now 7 is at the top and 2 is at the bottom, and we have a negative instead of a positive. So you can do that for anyone. For example, if you just have a gradient that's perpendicular and it's equal to 2, then you can just know that the gradient will be equal to negative a half, where I've just this is 2 over 1, where I've just swapped my numerator and denominator and then added a negative. Alright, now that we have this, I think that is actually the answer. We just needed to calculate the gradient of the line that's perpendicular. So this then is our gradient. So calculate the gradient of the line perpendicular to this line. So first thing I'm going to do is, if I have this line, I'm going to get it into its standard form by dividing every term with 2. So I have y equals to negative a half x plus 2. And that is our perpendicular gradient, which is negative a half. So my gradient of the gradient that I'm looking for, which is perpendicular to this gradient, I'm just going to swap my numerator and denominator and change the sign. So this will then be equal to 2. And I can test it. What is my gradient times my perpendicular gradient is equal to negative a half times by 2. And that is equal to, because these 2's, because this is over 1, these 2's will cancel, and then I'm just left with negative 1. So here is my gradient of the line that's perpendicular to this line. Example 13, determine the equation of the line perpendicular to this line and passing through the point. Alright, so now it's just one step further. We now need to find the equation. And once again, we can find the gradient by knowing, or by using the information that they give us from the perpendicular line. So the perpendicular line, if I put that in its standard form, that means I divide everything with 3. That gives me y equals to 2x minus 3. So if this is my gradient, my perpendicular gradient, which is equal to 2, this value over here, then my gradient of the line perpendicular to this line would then be equal to negative a half by swapping numerator and denominator and changing the sign. Right, so what do we need to find a straight line? We need either 2 points, or we can have a gradient and a point on the line. That's enough information to find the equation of a straight line, and the standard form is y equals to mx plus c, and we already have the gradient, so we just substitute in the point and find the c value. And once again, you can also use this y minus y1 equals to gradient x minus x1, but for this example I'm just going to substitute in my points into this standard form. So for the y value is 3, and my gradient, which we know is minus a half, my x value is 4, and then I just solve for the c value. So multiplying these out will give me minus negative 2 plus c. Then c is equal to, if I take the 2 over to the other side and it becomes positive on that side, then c will be equal to 5. Now we need the equation, so we know the equation standard form is this, and we just solved for c and we solved for m. So therefore the equation of my straight line is y equals to negative a half x plus 5. Then for question 13.1, determine the equation of the line perpendicular to this line and passing through this point. So we know we want the equation y equals to mx plus c. Let's first find m, and we can find it with this information over here. We start with the line 2y plus x equals 8, and we need to put this first in a standard form so that we can get the gradient from there. So starting to just to take the x to the right hand side, so 2y is equal to negative x plus 8, and then divide everything with 2, y equals to minus a half x plus 4, and then I know there is my gradient. So my perpendicular gradient is negative a half. Now to find the gradient of the line that I want to find, or the equation of the line I'm looking for, we have that the gradient will then be equal to positive 2. Right, so gradient is found. Now to find the c value, this time let's do it by substituting it into this form where we have x minus x1, and then we substitute in our point. Our y value is 4 minus 4 equals to the gradient is 2, then x minus my x value is negative 2. Right, so y minus 4 equals, so if I substitute it in, or if I multiply in the 2, we get 2x. This becomes plus 2, multiplied by this 2 gives me plus 4. And then taking the 4 to the other side, we have y equals to 2x plus 4 plus 4. So y is equal to 2x plus 8. And this is then the equation of the straight line that is perpendicular to this line and passing through the point M. So example 14, determine whether triangle EFG is a right-angled triangle. So here we have this triangle, and how are we going to find out if it is a right-angled triangle? We know right-angled triangles are 90 degrees, so this one over here, and it looks 90 degrees, but we know from, if we are working with a mathematical problem, we cannot just assume that the sketches are drawn to scale or drawn accurately. That's always a very important thing to remember. You can't read off what the sketch looks like. You have to go according to the facts, what the coordinates tell you or what the data tells you. So how do we know, or how are we going to find out whether this is a right angle triangle? Now we know from perpendicular lines, we know that their gradients must be, if I multiply the two gradients, they must equal to -1. So that means in order to test that, I first need to find out what's my gradient of FG, and I also need to find my gradient of EF. And then I can multiply them together, and if they are equal to -1, then therefore these two lines will be perpendicular, and if these two lines are perpendicular, then we have a right angled triangle. So let's start. We've got gradient of EF, and that is change of y, so E minus EF over XE minus XF. If I substitute in these values, I get E, so that's 5 minus 1 over -2 minus 0, -2 minus 0, and if I simplify, I get 4 over -2, which gives me -2, if I simplify that. Now, next one, gradient of FG, and that is change of y, f minus yg over x, f minus xg. Now let's substitute in these values. F is 1 minus 3, so 1 minus 3 over 0 minus 4, 0 minus 4. And that gives me -2 over -4, which is equal to a half. Now let's see what is gradient of EF multiplied by gradient of FG. So I substitute in those values, I get -2 times by a half. Now if this is over 1 and I multiply these two, this and this cancels, -1 times 1 is then -1. So since that is equal to -1, we can therefore say that EF, we can say therefore EF is perpendicular to FG, and therefore triangle EFG is a right angled triangle. Now for question 14.1, determine whether triangle ABC is a right angle triangle. So this then is what we need to test, whether AB is perpendicular to BC. So first of all, in order to test that they're perpendicular, we need to see, is gradient of AB, is it perpendicular, or is it gradient of AB multiplied by gradient of BC? Do they equal to -1. Now this line's gradient is gradient of AB, and this is the line gradient of BC, as a gradient of BC. So let's find the gradient there. Gradient of AB is change of y of A minus y of B over x of A minus x of B. Then substitute, we have 8 minus 2, so 8 minus 2 over 4 minus 3. And then that gives us 6 over 1, which is just 6. Gradient of BC is yb minus yc over xb minus xc. Substitute, so yb is 2 minus 1 over 3 minus 8. So this gives me 1 over -5. Now let's multiply them together. If I have gradient of AB multiplied by gradient of BC, that's equal to 6 times by -1 over 5. This is equal to -6 over 5. Now therefore, gradient of AB times by gradient of BC does not equal to -1. So therefore, AB is not perpendicular, AB is not perpendicular to BC, and therefore the triangle ABC is not a right-angled triangle. Next we have question 14.2, and the angle that we need to determine whether it's a 90-degree angle. If we want to determine whether triangle PQR is a right-angled triangle, we need to find out whether this gradient of PQ times by the gradient of QR would give us -1 when we multiply them together. So to do that, we need to find the gradient. So gradient of PQ is equal to YP minus YQ over XP minus XQ. And that is equal to the P value, so it's -1 minus 3 over -4 minus 2. -4 minus 2. So this will give me -4 over -6, -4 over -6 equals to 2 over 3. Okay, then to find gradient of QR, say YQ minus YR over XQ minus XR. Let's substitute. So YQ is 3 minus -3 over 2 minus 6. And this then is equal to 6 over -4, and that is equal to -3 over 2 if I simplify that. Now what is gradient of PQ times by gradient of QR? If I substitute in the values, we've got 2 over 3 times by -3 over 2. So the 2's will cancel, the 3's will cancel, and I'm left with -1. Now, since these two multiply together, it gives me -1. We can therefore say that the line PQ will be perpendicular to QR. And since the two lines are perpendicular, we can say, therefore, triangle PQR is a right-angled triangle. And that's all for perpendicular lines. Now let's look at how to find the equation of the median. For example 15, it says determine the median of triangle EFG passing through F. Now what is a median? A median is a line that goes from an angle, and this one says through F, so through F to the opposite side, but it has to go through the center, through the middle point of the opposite line. So basically we have this line, and it has to go through F and the opposite side through the midpoint of that line. So this is the midpoint then. Now, in order to find, well, we know this point. Now we need to find this point, so that in order to find the equation, the median is just the equation y equals to mx plus c, the equation of that line that goes through these 2 points. And we need to find point M. And in order to do that, we can know how to do it by using the midpoint formula, because we simply need to find the midpoint. So midpoint formula, if I say M, what is the midpoint? It's going to be of EG, it's going to be M, but then I have my x values added together, so xe plus xg over 2, and my y values added together, ye plus yg over 2. So now I just substitute that in. We have m, whereas our x values is minus 2 plus 4 over 2, and my y values is 5 plus 3 over 2. And to simplify, m is then minus 2 plus 4 is 2, so this is just 1, and 5 plus 3 is 8 over 2 is 4. So that is then my midpoint. Now, in order to find the straight line through 2 points, the first thing we want to do is to find the gradient. And finding the gradient, that's pretty simple. We already know y, so we want to find it between m and f. So ym minus yf over xm minus xf. Then we substitute in. We have 4 minus 1 over 1 minus 0. And our gradient will then give us 3. Okay, so now that we have the gradient, we can use this y minus y1 equals to gradient times x minus x1, and we substitute in any of the 2 points. I would recommend the point f, and then also the gradient, and just put it in its standard form. So y minus 1 equals to the gradient, which is 3, and then x minus 0. Then y is equal to 3, or y minus 1 is equal to 3x. We take the 1 over to the other side, so therefore y is equal to 3x plus 1. And this then is the median. That's the equation of the straight line that goes through the point F and through the middle point, through the midpoint of the opposite side. Question 15.1, determine the median of triangle ABC passing through B. Now, so we need to have this line pass through B, and it has to go through the midpoint of AC. So it's this line. So the median is just the equation in its standard form, y equals to mx plus c. So let's first start off by finding m, the midpoint. So the midpoint of AC is equal to m, where we take the x values, add them together and divide by 2. So that's 4 plus 8 divided by 2, and my y values, add them together and divide by 2. So that's 8 plus 1 over 2. And to simplify that, we have the gradient being, not the gradient, sorry, the m coordinates is 12 over 2 is 6, and 9 over 2 is just, let's just write it as 9 over 2. Right, so that's our midpoint. We have 6 and 9 over 2. Then we need the gradient. So gradient is equal to y, let's say ym minus yb over xm minus xb. And we substitute in our values. So ym, so we have 9 over 2 minus 2, 9 over 2 minus 2, over 6 minus 3. And let's just put that into the calculator. Then we have our brackets, and then we make another bracket where we have 9, not brackets, fractions, 9 over 2 minus 2 over 6 minus 3. And that gives us 5 over 6. So 5 over 6 is our gradient. And now we can substitute it into y minus y 1 equals to gradient times by x minus x1. And let's substitute this point in, especially because there's no fractions. So we have y minus 2 equals to, my gradient is 5 over 6 x minus 3. And then I just put it in standard form. Y minus 2 is equal to 5 over 6 x. If I multiply this in, the 3 and the 6 will cancel, so I'm left with minus 5 over 2. And then take the 2 over to the other side. Y is equal to 5 over 6 x minus 5 over 2 plus 2. And this is just equivalent to 4 over 2. So this will give me y equals to 5 over 6x. If I add 4, I get negative 1 over 2. And that is my medium passing through B. Then determine the median of triangle PQR passing through R. Now this point, and we need to find the midpoint of this line. And then we need to find the line that goes through these 2 points. Let's start with the midpoint. Midpoint of line QP is then M, where I take x of, or add the 2x, so x of P plus x of Q over 2, and y of P plus y of Q over 2. So if I substitute in these values, I get minus 4 plus 2, minus 4 plus 2 over 2. And here for the y value is minus 1 plus 3, minus 1 plus 3 over 2. And then simplify, we get minus 2 over 2, which gives us negative 1. And over here we have 2 over 2, which gives us a positive 1. Now to find the gradient of MR is then equal to change of y, m minus yr, over xm minus xr. Let's substitute. This is then, if this is minus 1 and 1, we have 1 minus negative 3, so 1 minus negative 3 over minus 1 minus 6, so minus 1 minus 6. And this then will give us 4 over negative 7. Okay, now that we have that, we have this line y minus y1 equals to mx minus x1, and we substitute in this point and this gradient. So we have y minus negative 3 equal to the gradient, which is negative 4 over 7, and then x minus 6, which is this x value over here. And then we just put it in standard form, so y plus 3 equals to negative 4 over 7x. Then multiplying this to the second term in the bracket, we have minus and a minus becomes a plus. Then this is 24. 4 times 6 is 24 over 7. And then we just bring the 3 over, so y is equal to negative 4 over 7x plus 24 over 7 minus 3. So this is y equals to negative 4 over 7 x. If this is 21 over 7 and I subtract 21, then I get 3 over 7. Or you could just type that into the calculator. But this is then the median that goes through R. So that is now equation of the median. Let's now look at perpendicular bisector. Now in this example, it says in triangle EFG, determine the perpendicular bisector of the line. All right, now there are two very important words in this sentence. The one is perpendicular and the other one is bisector. So bisector means that you are cutting a line in half. It bisects it. And we need to find the perpendicular bisector of the line FG. So that means we need to find a line that cuts this line in half, FG in half. But the other important word is perpendicular, which means it has to cut it in half, but at a 90-degree angle. So that means cutting it there at 90 degrees. So what do we need to find in order to find this equation? We need to first of all find where this point is, and we know that if it cuts it in half, this must be the midpoint of FG, and then we need to find the gradient. Now then, that means we need to find the gradient of FG and find the perpendicular gradient, which we then use to find the straight line. So there's a few things we need to do. Let's start off by finding the midpoint. So finding the midpoint of FG, we know that is equal to the x's add together the x, so that's 4 plus 0 over 2, and adding my y's together divided by 2, so that's 3 plus 1 divided by 2. So m's coordinates are then 2 and also 2, because 4 divided by 2 is also 2. Right, that's found. Now we have a point where the line goes through, but now we still need to find the gradient. So let's find the gradient of FG. So we know it's change of y over change of x, so it's 3 minus 1 over 4 minus 0. And that is equal to 2 over 4, which is equal to a half. So if this is then the gradient, we know that the gradient perpendicular to that line, this gradient, is then going to be, if I find the perpendicular gradient, I just swap around the numerator and denominator and change the sign. So this will then be negative 2 over 1, or just negative 2. Okay, and now finally we have the point that the line goes through, and we have the gradient of the line. So now we can just use this equation once again, where we just substitute in the point and the gradient, and we have our equation of our line, or in other words, a perpendicular bisector. So this is then y minus 2 equals to negative 2, x minus 2. That's my x value over here, and that's my y value, and that's my gradient over here. Okay, and then y minus 2 is equal to negative 2x plus 4. That's if I multiply in the 2 to both of those terms. And then last thing I need to do is to take the minus 2 over to the other side. So I've got negative 2x plus 4 plus 2. And therefore, we have y equals to negative 2x plus 6. Question 16.1. In triangle ABC, determine the perpendicular bisector of the line BC. So once again, remember the two words, bisector and perpendicular. And for bisector, because it cuts it in half, you need to find the midpoint. And for perpendicular, you need to use the fact that gradient times by the perpendicular gradient will be equal to minus 1. And we need it for the line BC. So that means the midpoint of the line BC and the line that goes through that point perpendicularly. Okay, so starting once again to find the midpoint first. of BC. We know it's just where we add the x values, 3 plus 8, and divided by 2, and add the y values, 2 plus 1, and divided by 2. So this then would be 11 over 2 and 3 over 2. Right. Then we need to find the gradient of that line. So the gradient of BC is change of y, so 2 minus 1 over the change of x, 3 minus 8. So this is then 1 over negative 5, and that is our gradient. So here we have a point and a gradient. It's not very simple, they're all in fractions, but we just follow our normal routines where we take, also now that we have the gradient of BC, this is actually, we need to find the perpendicular gradient of that line. So the perpendicular gradient is, if I change the numerator and denominator around and change the sign, I get 5. So that's much simpler to work with. So y minus y1 equals to gradient x minus x1. And substitute in my y value is 3 over 2. And gradient is minus 1, that's 5. Not minus that, that's 5 times by x minus that x value, 11 over 2. Then we simplify. Y minus 3 over 2 equals to take the 5 inside to each term, so that becomes 5x minus 55 over 2, and take the 3 over 2 over. So y equals to 5x minus 55 over 2 plus 3 over 2. Alright, that's easy to add. Y equals to 5x minus 52 over 2. So minus 52 over 2, or let's just put this in the calculator because this is going to simplify. If I say minus 55 over 2, and then plus 3 over 2. It gives me negative 26, minus 26. All right, there we have it, our perpendicular bisector. For question 16.2, in triangle PQR, determine the perpendicular bisector of the line PQ. So line PQ is over here, and we need to find the bisector, meaning the midpoint, and also the line that goes through it, but at a 90-degree triangle. Ooh, this is a bit hard to draw. Okay, so then we have to find the midpoint first. So midpoint of PQ is equal to my x values added together, so that's minus 4 plus 2 over 2, and my y values minus 1 plus 3 over 2. So the midpoint M is minus 2 over 2, which gives me negative 1, and then 2 over 2, which is just 1. All right, that's easy enough, or simple enough. And then for my gradients, now I need to find the gradient of PQ. So this is then the change of y, which is 3 minus negative 1 over 2 minus negative 4. And let's simplify that. This becomes 4, and this becomes 6, which is then 2 over 3. And to find the perpendicular gradient of that, it's going to be negative 3 over 2 when I swap my numerator and denominator and change the sign. Okay, now we have everything we needed, which we can just substitute into this line, x minus x1. And then substituting in our point over here, our y value is just 1, so y minus 1 equals to my gradient is negative 3 over 2. So x minus my x value is negative 1. And simplify. Y minus 1 equals to, let's multiply this minus 3 over 2 in, minus 3 over 2 x. This becomes plus 1. But if I multiply it with negative 3 over 2, it becomes negative 3 over 2. and take the 1 over, y is equal to negative 3 over 2x minus 3 over 2 plus 1. And that simplifies as negative 3 over 2x. This is the same as 2 over 2, so this would be the same as negative a half. And that's my perpendicular bisector. Alright, so we have worked through all of these, and that means we are finished.